Hi, everyone. It is a pleasure to be talking to you today. I am currently a postdoc at the Center for Science and Innovation at Northwestern University, a few miles north of here. Uh, I did not hit that slide. And formerly a postdoc in the laboratory of Luis Amaral. I am here to talk to you today about scanning electron microscopy. So we started this study, which, by the way, has now been published in PLOS One. You can scan the QR code in the top right of the slide, because we were looking for a tractable, discipline-specific signature for material science that could flag potentially problematic articles. Particularly because we know that many paper mill articles are just not detected, let alone corrected or retracted. Some other signatures that have been developed and used with varying scalability and varying suggestiveness of paper mill involvement. I am not doing that on the slides, but I'll just ignore it, I guess. Um, aren't seeing what I'm seeing on the slide, but whoever's in charge of this is an expert. So props to them. And it's fixed. Look at that. So, some other signatures include image manipulation and duplication, like we just heard about, tortured phrases, inexplicable references. But we wanted to see if we could find one that was discipline specific for material science. So, to that end, we turned towards scanning electron microscopy images. This is a very popular technique in material science for visualizing microscopic structures. Here's an SEM image up here, and you'll notice that the SEM image actually has metadata at the bottom. This is what we were calling a metadata banner. And depending upon who manufactured the instrument, this will tell you when the image was taken, where it was taken, the scale of the image, the instrumental settings, etc. A lot of time it gets cropped out because, let's face it, it's not very pretty. But there is crucial data in here for the reproducibility of the image itself. And we were reading through PubPeer comments on a Saturday afternoon, and when we noticed that there were a few PubPeer comments about instrument misidentification, where these metadata banners could be seen. This is one of them. This is a study that had an SEM image in its main text figures. And you can see that metadata banner in there tells you that this image was taken on a test scan Mira 3. However, the methods section of the text indicates that the image was taken on a Leo 1455 VP. These are different instruments from different manufacturers. And this is precisely the sort of basic information that you would hope a study gets right. Depending upon how charitable you're feeling, this could be an indication that other information in the study is unreliable. So we wanted to see if we could semi-automatically flag instances of SEM misidentification like this, starting from a large corpus of articles in the material science and engineering literature. I don't have time to get into the nitty-gritty of the pipeline itself, but in short, it involves optical character recognition and manual comparison of the extracted text from both the image and the text of the article itself. And in the end, we narrowed down to around 11,000 articles for which these metadata banners were still inside the article. And among them, around 2,800 did not identify the SEM that they had used in text at all, and 2,400 misidentified the SEM that was in one or more of their figures. Among those, the vast majority misidentified both the model and manufacturer of the instrument that was used. So we wanted to validate our pipeline. So first, to get at the false discovery rate that we were looking at, we took a sample of 150 articles that we had flagged as having SEM misidentification, and we manually inspected them. Among them, there was only one false positive that was due to a mistake on my part because I was very tired while I was doing this. And we noticed that for the majority of the cases, there was no alternate explanation for why the SEM might have been misidentified, like there being multiple instruments used in the study and they really only documented one in the methods section. So this tells us that our semi-automated pipeline has a low false discovery rate. But we also wanted to get at the false negative rate of the pipeline. For that, we looked at 45 existing comments on PubPeer that fell within our corpora, and our pipeline only caught 13 of them. So this pipeline does have a high false negative rate. However, if you take the 2,400 articles that we flagged and then look for pub peer comments on them, only 13 were actually flagged on pub peer as having SEM misidentification. So this is one instance where it might be valuable to automate things as opposed to having people go through the literature in an artisanal fashion. We wanted higher confidence that what we were looking at was a tractable signature for flagging papers for further scrutiny. So we looked for a specific methodological error in a subset of articles about electrochemistry. And we found that the articles that misidentified their SEM were almost twice as likely as other articles to have this critical methodological error in a part of the study that was unrelated to the SEM. So this let us know that we might be on to something with this signature, which somewhat weakly indicates that something went wrong with a study. When we looked at the authorship of the articles that were producing these studies, we found various patterns in the countries that these authors came from. For instance, articles that had authors from Iran or Iraq were almost 6 times as likely to have SEM misidentification as articles that did not have authors from these countries. And we weren't able to do very large scale author disambiguation, but we were able to identify the 5 authors that had the most problematic SEM misidentifying articles. And these authors that you can see in the right graph did this repeatedly. They also have had highly prolific publication patterns, often putting dozens of publications in the same journal in the same year. And I can tell you now that at least 2 of these authors now have multiple retracted publications to their name. Uh, and we suspect, because of this highly repetitive authorship, that paper mills were involved in a large part of these articles. And we have some other evidence as to why that might be. For one, there were a lot of articles that were green synthesis of silver oxide nanoparticles using ginseng leaf extract. Some people are chuckling because they've seen these kind of articles around. These sort of formulaic titles were very common to the extent that you could look for specific tokens in the title, and those were very strong indicators that it would also have SEM misidentification. You could also look at the metadata banners that told you where the images came from, and many of the images had unexplained shared provenance. So, for instance, many images appeared to have come from Amir Kabir University, despite the authors not having affiliated with the university nor having acknowledged it. And a lot of these articles did not have authorship in common. There were also text signatures that clued us in that the text, at the very least, was probably plagiarized. For instance, there we saw dozens of articles that had the phrase Philips X130 and Cambridge instrument in them. One, the type of Cambridge instrument that they're not using is not specified. Two, this is exactly how it was phrased every time. Three, it is not a Philips X130, it's a Philips XL30. So the fact that the same typo was happening repeatedly in articles that did not share common authorship pointed to us that these articles may have came from the same place. And finally, among the journals for which we found the most problematic articles, we also noticed a lot of these journals appeared very frequently in paper mill advertisements, where they were held up as this is a place where you can get your article published for a fee. Um, you'll notice that many of them are Elsevier journals. That is largely because we were mostly looking at Elsevier journals because of their relatively permissive text and data mining agreements. And I can talk more about why permissive text and data mining agreements is important for this work if you'd like. Um, but all in all, this gives us more than enough reason to suspect that paper mills were involved with a lot of the articles that we're seeing here. So in short, we built a semi-automated pipeline to find this signature. It can be applied on a artisanal article by article basis, or you might be able to use some of the data that we've extracted to build a training set for a much better tool, with a much higher sensitivity to this sort of thing. And I'd also like to emphasize that images are data, and metadata is a crucial part of images. We were talking about image provenance analysis earlier. So They should be included, particularly where they form a crucial basis for actually reproducing the results shown in the image itself. Thank you for listening.
Hi, I'm Alex Goldberg from the Computer Science Department at Carnegie Mellon University. Thanks for a super interesting presentation. I was wondering, based on your main result, it suggests that more than 1 in 5 of these papers have mismatch between the SEM text and what's in the paper, which seems like an incredibly high prevalence of issues. Do you think there's some explanation for why that is so high, or is it really the case, in your belief that in the material science literature, there's like this high of a rate of misreporting?
So certainly. So I will say that a lot of countries are also overrepresented in who actually includes the metadata banners. So many American scientists will get rid of them, again, because they're kind of ugly. And other scientists from other countries will include them in the articles. So I think that has a lot to do with it. We could only assess the instances for which we had sufficient information to make a determination. If the metadata banners aren't in the article, the rate of SEM misidentification is entirely unknowable. So I would venture a guess that the true rate of SEM misidentification is lower than what we report of that 1 in 5 figure. Um, but it is, we would need that metadata if we are to know for sure. Thank you.
Randy Ellis, Harvard Medical School. Great talk. Closely related question. So you highlighted about 11,000 papers that had the metadata banner. How many didn't have it? So like what was the total set of papers that you assessed? And could a bad actor simply not put the banner in their paper?
You're absolutely right. And you get to a really interesting irony of this work, which is that only because people took this unnecessary reproducibility step that is quite rare were we able to spot instances where it had gone wrong. Um, so we narrowed down from a set of 1 million to around 174,000 articles that had SEM images in them. And from that, we got the 11,000. So the metadata banners are very frequently removed. However, we were using optical character recognition to recognize them, and it was very resolution dependent. One thing that I hope would be easier for publishers to adopt before they adopt image provenance analysis is not publishing images that are 4 pixels wide by 16 pixels. Like that just shouldn't be acceptable in the year of our Lord 2025, right? We should be putting better quality data out there. But yeah, thank you for your question.
So we should definitely require the banner then.
I would say so, but I am not personally a material scientist. I would advocate for it. And if there are many material scientists in the crowd, I would love to hear your opinion about it.
Thank you so much.
Hi, Nick DeVito, University of Oxford. So I think you're being overly generous slightly by saying that they took a reproducibility step. I imagine they were potentially putting a fake image in there anyway. They just didn't care enough to crop it before they put it in the paper, to the point you just made. But my question is, are there other, like, this feels like a decently low-hanging fruit, and very much kudos to you for recognizing it and building the pipeline to do it. And as far as imaging goes in other disciplines or in other types of imaging, are any other types on your radar where this can be a transferable and automatable step to match equipment to materials and method sections and papers?
I would hope so. I can tell you that there's a lot of metadata embedded in like biological microscopy images, but not actually shown in the image itself. Transmission electron microscopy has very limited metadata, which is interesting because it's very closely related. Um, uh, I've lost my train of thought. Could you could you condense it?
Just well, like, so I guess that speaks to it, but like there's like embedded in the text that conveniently to where you could OCR it and, get it out quickly. And like, I'm just wondering if like you've seen this and you're like, oh, where else can we apply this,
Right.
Yeah.
I've been looking for this sort of stuff, but in the published literature, again, it seems like a lot of this metadata gets removed quite frequently. So this might be a case where it is a very specific application, but I would welcome ideas on if there are other kinds of microscopy where this actually shows up quite frequently.
Thank you.
Thank you.
Hi, Tim Miller from Boston Children's Hospital. I'm wondering if you could take the subset of the data where the metadata is in the image and use it to train a classifier to distinguish between different machines, and then apply that classifier to the rest of the data and see whether the non-metadata things also have this problem with the.
That is exactly what we were hoping the next step would be. We share all of the data in the article. Unfortunately, we can't share the images themselves because of copyright agreements, but we do tell in the article, like, this is where you can download the images from the publisher themselves. So we have that, the basis for a training set if somebody wanted to take that on. A great idea.